All right, students, we made it to the second lesson for Module 1, and this one's going to be much shorter than the first. We're just going to extend our knowledge of what we've learned about the equation of a circle so far. Sorry, that's my email notification going off in the background. Let's take a look. Just to revisit the circle equation, we said that to write an equation for a circle, we really only need the center, and we need the radius, or we need the radius squared. Sometimes we'll come across the radius squared and we won't actually have to solve for the radius. So those are the two pieces of information that we need anytime we're going to write the equation. Let's look at this first example. We're asked to write the equation of a circle. We're actually given the equation of the original circle, but we are asked to translate the circle to the left 5 units and up 1 unit. So just a really quick recap, I'm going to go over here to the side. In semester 1, when we learned about the 4 different types of transformations, I'm just going to abbreviate that. We said that there are 3 transformations that we can call isometries because they produce, oh my goodness, my pen is not working very well. They're called isometries because they produce congruent figures. And we said that list includes the translation. Oh my goodness, come on, translation. I'm just gonna abbreviate. The reflection and the rotation. And then we said when we talk about dilations, that those produce similar figures. So a dilation could cause a shape, whether it's a circle or anything else, to cause it to get larger or smaller. But if we're just translating the circle, all that means is we're just moving the circle, either to the left or the right, up or down. So when we write this equation, if we're translating it left and up, the radius is not going to change because the circle's not getting larger or smaller. So what I would do is I would write down the information we know so far. We know that the current center is at +2, -3. So don't forget there's sort of a sign change there, that when we have subtraction, that value is positive. When there's addition, it's like saying y minus -3. And then our r squared value is 14. We don't really need to write the radius out, but just remember the radius would be the square root of 14. Okay, so all we really need to do is move the center of the circle. We're going to keep the r squared value the same. If we move the center, we'll move the whole circle. So if I want to translate a point left and up, remember that we move left to right parallel to the x-axis. So I can write a translation rule of x minus 5. So when I subtract 5 from any x coordinate, that's going to cause a point to move to the left. And when I add 5, it would move to the right. And then if I want to go up 1 unit, I know I move up and down parallel to the y-axis. So I could write y plus 1. And by adding 1 to any y value of an ordered pair, it will move up. So we only need to do that to the center. So if we plug the center in, that 2, -3, if we plug that into that rule that we just wrote, 2 minus 5, in fact, I'm going to write my new center out here. I'm going to write new C, my new center. 2 minus 5 is -3, and -3 plus 1 is -2. So we're just moving the center from 2, -3. We're moving it to the left 5 units and up 1 unit. And now we can use this information to write our new equation. Oh, I'm having some technical difficulties. If my pen dies, we're in big trouble. All right, so our new equation would be, in parentheses, x plus 3 squared plus y minus 2 squared, and that would equal the r squared we said does not change, so that would just equal 14. All right, I'm gonna try for the rest of this video to lay my computer flat so you won't see me in the screen at the top, but I think that'll help the problems I'm having with the pen right now. So let me try that. All right, so in example 2, we are given the center again. So this is our h comma k. Oops. And we are also given the circumference of the circle. So for circumference, we've got to remember that we have two formulas for circumference. I could either think of circumference as pi times the diameter, or I could think of circumference as 2 times pi times the radius. Remember from everything we talked about before spring break that when we double the radius, that gives us the diameter, or if I divide the diameter by 2 or multiply it by 1/2, that gives me the radius. So that's why we write these two different equations. So again, for our circle equation, we only need to know the center, which we already have, like this is h comma k. And we need to know the radius squared. So since we need to find r, the version of this equation that I think it makes the most sense to use is 2 pi r. So if circumference is 2 pi r, and this is the circumference, we could set this equal to 2 pi r. So 2 pi times the radius equals the circumference we're given of 2 pi times the square root of 5. Now our goal is to solve that for the radius, which I can do on the left side by just dividing by 2 pi. And if whatever I do to the left side, I do to the right side. And 2 pi divided by 2 pi is just 1. So when we solve this, we get that the radius equals the square root of 5. Now we don't want the radius, we want r squared, but that's easy. When we square the square root of 5, squaring a square root, those things undo each other, so to speak. So the square root of 5 squared is just the number 5. The exponent and the square root cancel out. So to write the equation, we've already got our center. So x minus h, so x minus 3 squared plus y minus k. And instead of writing y minus -4, I'm going to just write y plus 4. And then that equals r squared, which we said is 5. All right, one last example. Sorry, this little PDF is in the way. I couldn't move it. We're doing a very similar thing to the problem above. We're given the center, but we are given an area instead of a circumference. So the thing that needs to change is when we find the radius, because we already have our h comma k for the center, when we find the radius or the radius squared, we need to use the formula for area, which is pi times the radius squared. So that's good news for us. It already has r squared in it. So if I set pi r squared equal to 12 pi, so pi r squared equals 12 pi. If I want to solve for r squared, I could just divide both sides of my equation by pi. So when I do that, pi divided by pi is just 1. I'm left with r squared, the radius squared, equals 12. If I want to know the radius, I could take the square root, but we don't even need that. So now we're ready to use the standard form of our equation. So x minus h would be x minus 0. I'm gonna change that in just a second. Squared, of course, plus y minus k, so y minus -1. Again, this is what causes this to become addition, that it's plus a positive. And then we said for r squared, we got 12. So that would all equal 12. When we rewrite this, instead of writing x minus 0, it doesn't matter what x is. If I subtract 0 from x, it's just x. So instead of writing x minus 0, I would just write x squared plus y plus 1 in parentheses squared equals our r squared value of 12. So I know the first lesson, 9.5, had a lot of information in it. And so we decided to kind of make this one a little bit shorter so that you're not like totally overwhelmed. So after this video that you just finished watching, there'll be a quick little check for understanding, and then you'll be able to move on to some other assignments in this folder. All right, don't hesitate to reach out to me if you have questions, and I'll talk to you soon.